Chapter 11, Industry Key Issue 2. The national standard, which is the learning objective, is describe the patterns of production and economic development with the distribution and trade of fossil fuels amongst countries or states. Your ICANN statements. Explain the principal source of demand for fossil fuels. 2. Explain how the uneven distribution of demanded resources created a wider gap or development gap between MDCs and LDCs. Describe the distribution, production, and consumption of the three fossil fuels. Analyze the distribution of reserves of fossil fuels and differentiate between proven and potential reserves. Describe the role of OPEC and changes in the price and availability of petroleum. Explain future petroleum production trends in the United States and Canada and how that will affect development of OPEC countries. In the world, we see developing countries have, there's interregional variation in GDP. Most of the 20th century, the gap between the rich and the poor narrowed between developed countries. Since the 1980s, inequality has increased in most developed countries, including the United States and Great Britain, United Kingdom. We see the widening gap here in the United States and the UK since the 1980s to current. When we look at that, it ties into energy and resources. When we talk about energy resources, historically people used animate power, which was 5/6 of the world's energy. And then more recently, now we use 5/6 of the world's energy through fossil fuels. And with that, we see the demand is the quantity available. And demand is also the ability to buy, and supply is the availability to sell. When you look at fossil fuels today, they are residue of plants and animals buried millions of years ago. The sediment accumulates sediment accumulated over these remains. Intense pressure and chemical reactions slowly converted them into fossil fuels that are currently used. When the substance is burned, energy that was stored in the plants and animals millions of years ago is released. Coal is 27.9% of the world's consumption. Coal, North America and Europe developed rapidly in the late 1800s because of coal, the supply of coal. And now what we see with coal is the greatest energy demand for coal is going to be in developing regions. Petroleum, first pumped in 1859. It's important for motor vehicles in the 20th century and the 21st century. Petroleum consumption represents 33% of all energy consumed. Natural gas has traditionally and most recently heated homes and also used to produce energy. All these fossil fuels are non-renewable, as you learned in Unit 1. Non-renewable means they're finite. They have a carrying capacity, a limitation on how long they will last. When we look at the energy demand, we can see that world's energy is currently divided equally amongst developed and developing countries. We can see that developed countries consume about half the world's energy and developing countries consume half. However, the much faster rate in developing countries will increase the demand to 60% of all energy's resources by 2040, according to current United Nations estimates. The highest per capita of any country is the United States, and the United States consumes 1/4 of the world's energy. And then we can also see the per capita consumption is greatest in the United States. It's 3 times greater than the developed countries. Here we look at BTUs, so the energy measurement of consumption per capita. We can see the numbers in the last slide represent those countries that are mostly in the core, and then we can follow development patterns. So those countries in the periphery that are have a low HDI, such as sub-Saharan Africa, don't use a lot of energy in BTUs. Energy resources are not distributed equally. When we look at the distribution of coal, for instance, coal formed in tropical locations, but over time it is converted to middle latitudes. So when we look at the middle latitude countries, China produces nearly 1/2 of the world's coal, and then the U.S. Has 1/4 of the world's coal. When we look at the distribution of petroleum, petroleum is a residue deposited on seafloor, commonly found in seas of the Persian Gulf and North Sea. Other reserves are found beneath land, like in Russia and Saudi Arabia. Together, Russia and Saudi Arabia supply 1/4 of the world's petroleum, and half of the petroleum in the world is found in Southwest Asia. Meanwhile, the United States has the remaining 1/4 of the global supply. But keep in mind, the United States also consumes 3 times the amount of other developing regions. They consume about 1/4 of the world's energy, as mentioned in the previous slide. And then we also see Canada, which is reclassifying tar sands, which shows that they control about 10% of the world's petroleum. I'm sorry, of coal. Actually, the tar sands are not coal, they're petroleum. All right, developing countries' use of fossil fuels growing, as already mentioned. They eclipsed half the world's fossil fuel consumption in 2020. They are, as already estimated, you're going to consume 60% of the world's energy. The largest growth is in China and India. We also look at the Asian dragons and BRICS and the baby tigers, rapidly growing newly industrialized countries and post-industrialized countries, such as the Asian tigers, or sometimes referred to as dragons, of Singapore, South Korea, Taiwan, and Hong Kong. And then you have BRICS, Brazil, Russia, India, China, and South Africa. And then the baby tigers, those are going to be in Southeast Asia, where we see the highest fossil fuel consumption. We see that all these countries that are now industrialized and are using fossil fuels, non-renewable fossil fuels. We do see some electric generation for vehicles, but also in these areas, with the result of increase of economic development, the increase of non-renewable energy sources, and then increase of pollution. Here we look at the coal production in the world. Current proven estimates according to, I'm not sure, it doesn't say according to, but in your textbook it says proven reserves will last 110 years with current consumption patterns. And we can see the largest coal producers, China and U.S., account for 3/4 of the coal production in the world. All right, then we look at petroleum production. As already mentioned, Southwest Asia and Northern Africa encompass half of the world's petroleum. Then we can see large petroleum reserves, and 1/4 of it's in the U.S. and then Russia. Proven reserves of petroleum would last 43 years with current consumption patterns. Venezuela and Saudi Arabia are the 2 leading locations of proven petroleum reserves. So here we have Saudi Arabia, and then we have Venezuela in South America. They have the largest proven reserves of anywhere in the world. Here's a look at the UAE. And again, the UAE has used the petroleum to develop rapidly, where now they are a post-industrial country where most of their jobs are in the tertiary sector, and with that they've developed across many high-skilled secondary as well as tertiary sectors, where now the quality of life is increased, where we're seeing modern high-rises and consumption patterns that would be found in mass consumption stage 5 at Rosthaus. When looking at natural gas, we can see natural gas is their proven natural gas reserves would last 54 years. Natural gas is a little bit more spread out or dispersed, unlike petroleum and coal. Natural gas, we see a lot of the distribution is in Iran, Russia, and Qatar have half of the world's natural gas. And third is found in the U.S. Here's the distribution. And again, we should be able to see Venezuela up here. Or I'm sorry, Iran. Oops, there's Russia. And then we go down here to Iran, and then also Saudi Arabia. Those three countries have half of the world's natural gas. All right. When looking at demand and supply, there are two types of energy. Proven reserves, meaning they've been discovered, they exist, they're reliable. Potential reserves are it's that they're thought to exist. There's a potential reserve is actually, when a potential reserve is discovered, it is reclassified as a proven reserve. So they don't currently exist, but they're potential through advanced technological surveying of land to find locations where these potential reserves might be. Proven reserves already mentioned, the carrying capacity, which is listed below. Here we have proven reserves, again the distribution amongst developed countries and developing countries. Here's a look at consumption patterns to 2035, and we can see the growth of natural gas, but the decline in crude oil. All right. Fields yet to develop. This is when it first was exploited, petroleum gushed in wells, but now it's when we find it, it's these fields yet to be discovered. It's like wringing a wet towel. So the volume of crude is very minimal. Fields yet to be discovered can also be very difficult to access. So oftentimes they're generally smaller and more remote. All right, and as already mentioned, undiscovered fields, small and remote. Enhanced recovery. These are techniques like we see with hydrofracking. And then unconventional sources. And these can be like the oil sands in Alberta, Canada, where Canada's been able to extract this tar-like substance that has a strong odor and a dark color and extract the petroleum from that tar, which has led them to control 10% of the world reserves of petroleum. OPEC, the oil petroleum exporting countries is what the acronym stands for. Those are countries that are largely found in Southwest Asia. They can control oil prices. They have historically since the 1970s. Most of those regions were exploited by developed countries until the 1970s. Then in the 1970s, OPEC formed a cartel, an alliance amongst Southwest Asian countries. And then OPEC countries in the 1960s were able to, prices were set by governments rather than petroleum companies. So they removed the foreign petroleum companies, and now the governments in these regions set the prices of the price of petroleum. Keep in mind that when we think of OPEC, we're thinking of countries that are mostly non-secular, meaning that religion ties into the government, and the government makes decisions on oil. And most of those governments are autocratic governments and not democratic. So when we look at the flow of oil, it used to flow through these oil petroleum exporting countries to Europe and the United States. However, more recently we've seen, being that there's a conflict between types of government, the largest flows are now from Russia to Europe and Canada to the United States. The United States and Europe import more than half of their petroleum, and Japan imports more than 90%. But again, with this movement, new flows of petroleum in the 21st century, we're seeing seeing the diminishing power of OPEC with controlling oil prices. However, in the future, we know that most reserves are found in these regions, over 50% in Southwest Asia and North Africa. Here's a look at the consumption of barrels per day. All right, so we see sharp prices determined by the government's OPEC countries, mostly Persian Gulf states, including but not limiting to Saudi Arabia, Oman, Qatar, United Arab Emirates, and like Nigeria and West Africa and Venezuela and South America. They're all OPEC countries. I would encourage you to go ahead and Google OPEC and take a look at the members of the cartel of OPEC. Again, we see price adjustment for inflation, and petroleum plummeted in low levels during the 1990s. And then we see now petroleum still growing mostly in developing countries. Excuse me, mostly in China and India. Here's the harvesting of illegal diamonds, so non-ferrous metals. All right, and that'll take us to the end of notes today. Oh, actually, let's keep continuing here, because this is all one key issue. All right, let's take a look at the following ICANN statements. Describe the distribution of nuclear energy and challenges in using it. 2. Identify challenges to increasing the use of alternative energy sources. 3. Identify how passive and active solar energy is used as two means for renewable energy. And 4. Explain the various forms of renewable energy and how they can help eliminate environmental concerns. All right, nuclear energy, also referred to as alternative energy. Alternative energy to fossil fuels. There's a large amount of energy released from a small amount of material, unlike most non-renewable fossils or sources of energy. But it presents some serious challenges. When we look at the distribution of the world's energy, 14% uses nuclear energy. 2/3 of that energy is found in developed countries within Europe and North America, which generate about 1/3 of all nuclear energy each. When we look at Europe, there are several countries that have high energy usage, such as France, that uses 80% of their electricity comes from nuclear energy, and then Belgium, Slovakia, and Ukraine has 50% of its energy coming from nuclear energy. When we look at North America and where we see nuclear energy, we see most of the nuclear energy in the Northeast, with Vermont has 1/2. 70% of electricity in Vermont is nuclear energy, and more than 1/2 of nuclear energy is used in the states of Connecticut, New Jersey, and South Carolina. And there are 20 states that do not use nuclear energy in the U.S. Fission is the splitting of uranium atoms, and that's how you get the energy, this highly active energy. But the negative effect is there's radioactive waste. And so with the radioactive waste, there's the potential for nuclear power plants to melt down. They don't explode, but they would melt down, where we've seen in the past with Chernobyl in 1986, where it's killed 56 people and 4,000 people have cancer-related illnesses. And then more recently in 2011 with the Japan's Fukushima Daiichi nuclear power plant, it was a full meltdown. And it was, and we don't know the effects of it because it was so recent to really explain what the residual effects will be. Here we look at nuclear power. Again, 2/3 found in Europe and North America. Here we look at the distribution of nuclear power in the United States. Remember, Vermont has over 70% of nuclear power. The radioactive waste is a concern. It's highly radioactive, so it's lethal to humans. So it can burn or chemically treat. They're not possible to burn or chemically treat. Oftentimes the waste can, when you can't burn it or chemically treat it, it can be used for nuclear weapons or nuclear warheads. Right now, what we've seen with radioactive waste, there isn't a really sound solution or a sustainable solution. Mostly it's because of political opposition in the U.S. In 2002, Nevada's Yucca Valley Mountains were a funding site for a project, but it ended in 2011. We see radioactive waste in temporary steel and concrete caskets. Some waste is being stored at the Waste Isolation Pilot Plant below the surface in New Mexico, but these are really all temporary solutions. All right, and then the high cost. The nuclear power plants are extremely expensive. They're expensive for several reasons, because you need double and triple wall backup systems for the nuclear power plants. Nuclear energy would be too dangerous to use. Uranium is mined in one place and then refined in another. And then mining uranium can pollute land and water. The future of nuclear energy has been seriously hurt by the high costs associated with reducing the risks of the radioactive waste. Let's see. And then proven reserves of uranium is 124 years with current consumption patterns. And the price tag on according to the new text, the price tag on a nuclear power plant is about several billion dollars to build. Again, that price tag is just not feasible for future movement to all nuclear energy as alternative energy. Other energy, there is the hydroelectric power energy. It's the world's second most popular source of energy after coal. 2/3 of hydroelectric energy is in developing country. 1/3 is in developed countries. The most populous country that uses hydroelectricity is Brazil, where 80% of their electricity comes from hydroelectric power. Canada gets 60% of its electricity from hydroelectric power. And the United States leads in producing hydroelectric power, but only uses 8% for electricity. Biomass is another one. Biomass is the burning of woods, plant material, or animal waste, and you convert it to charcoal or alcohol or methane gas. This is an important fuel source in developing countries. It was once an important fuel source in developed countries, but we see the emergence of some rapidly developing countries using biomass. The waste of like sugarcane and soybeans can be processed in motor vehicle fuels. We see this being done in parts of developed regions like North America and Europe, but also developing regions like Brazil, where Brazil uses biomass to fuel its cars and trucks. There are limits to biomass, though. The energy used to produce the crops may be as much as the energy supplied by the crops. And then biomass also is essential purpose of other energies, such as Earth's food or clothing or shelter. And then the fertility of the forest may be reduced by by slash and burn or shifting cultivation or overusing of land's resources. Renewable energy, biomass, again, I talked about the limitations. Sorry, I didn't know if I had this slide. But again, I mentioned what those limitations are, and here you have them in text. Wind energy is another renewable energy source. Wind energy comes from, there's minimal impacts in the environment. However, there's complaints of degradation of the environment integrity. It has greater potential because right now there's a small portion of the wind harnessed for energy usage. And when we look at where wind energy is, it's not found all over the world. It's only found in a few places like China, North America, and Europe constitute 90% of all wind energy. The high cost of wind turbines is an obstacle for many areas of the world. 1/3 of the United States is windy enough where you see wind farms. You see these large areas of land where there's these turbines with large propellers that are usually through a flat area of land or through a pass and two mountains. The opposition to these are environmentalists. They can be noisy, they can be lethal to birds and bats, and they're just an eyesore. Here's a look at where we would see wind turbines. If you ever driven through like Indiana, there's a huge wind farm there. Huge wind farms in the San Andreas area, San Juan Jacinto area down here in California, and also up here in highlands, the high desert, like on the west or the east side of the Sierra Nevadas. But this is really where we get our wind in the United States. All right, solar energy. When we talk about solar energy, this is the most important or ultimate renewable resource for several reasons, because you can use this energy to operate any businesses, schools, and hospitals, so a large portion of your infrastructure. Currently, only 1% of electricity in the United States uses solar energy, and also the lifespan on the sun is 5 billion years, according to current scientific evidence. And you're incapable of destroying or depleting the sun. Nobody can own it. It doesn't damage the environment. So really, in the future, solar energy is what is seen as the ultimate renewable resource. When we look at solar energy, it's stored in two ways or two means. One is passive solar energy, usually with a mechanical device that will capture energy without using without a chemical or without a mechanical device. So you'll use energy within how you set up like a home. Windows, the advancements of Windows have really led to an increase of passive solar energy. The first things we saw were buildings facing south and larger windows in the south, and now we see windows that now can store energy, because with the gas technology there's higher insulation values like low emissions glass. The glass is filled with either argon or another gas that increases the insulating value, so hot air comes in and the window traps it inside and doesn't let it out. Those are passive solar energy. And the other type is active solar energy. This type uses mechanical devices to convert heat energy to electricity. It can be done so directly or indirectly. Most direct active solar energy is stored through photovoltaic cells. Cells are primarily built with silicon, and then the electrons excited through the light will move through the silicon, producing direct current or DC electricity. Inactive solar energy within active solar energy would be oftentimes pipes filled with synthetic oil. They generate steam to run turbines to heat the water or rocks, little sunlight, so they can just add more pipe, or they can add more reflectors, and they can have a larger storage container for areas that have little sunlight. When we think about solar energy, solar power can be produced at a central station and distributed by electric companies or utility companies. Currently have had little interest in solar technology. However, in developed countries, spacecraft, light power calculators, and then also we see these large solar farms, which in this picture right here, it shows in the Mojave Desert in California, solar power is used primarily as a substitute for electricity and heating water. We see also these rooftop devices collect heat and store water for apartment buildings, which is very common in Israel and Japan, and also homes in the United States. And here's this is a picture in Uganda. And then we look at Uganda because in developing countries, the fastest growing market for photovoltaic cells, active solar energy, is found in sub-Saharan Africa because of the lack of electricity. And so oftentimes, like in bazaars, which like in Morocco, you'll see solar panel photovoltaic cells for sale. And more recently, petroleum companies now in the major U.S. or in the U.S., the major manufacturers control photovoltaic cells. So petroleum companies, large ones, control photovoltaic cells. So we see the future with alternative energies or with renewable energy is most likely going to be solar. All right, and this shows you solar panels, again, helping provide electricity for nearly 2 billion people in sub-Saharan Africa. All right, in review.